So I would have, if I have 14 terms, right, I have 7 pair times my first term is 25 and my last term is 259. So we should be able to type that in and get the solution just using the formula. Seven times 25 plus 259. You guys all have a calculator because you're going to need to be able to do the sigma notation. So you need one? 1988. Are you with me on that? All right, so I just want to show you that you can get the same answer using sigma notation on your calculator. To me, this one was easiest using the formula. I didn't have to solve for any information, right? I was given everything I needed. Sigma notation, there's one other piece I'm going to have to solve for in this example. So I want to go from term 1 up to term 14, and I need to write out what the sequence is. I know that the starting term is 25, but I'm not sure what the common difference is to do the common difference times n minus 1, or x minus 1 in this case. Our calculator says x. For sequences, usually we say n. So how can I figure out the common difference? How far did I go, right? I went from 25 up to 259, so I could subtract those to find the total difference and divide by the number of terms to get the difference between each term. So what is 259? 259 minus 25 divided by 14 will equal D, right? Because I went from, so 259 minus 25, and I'm dividing by 14. Wait a second. Oh, I need to divide by 13, I think, right? Because I didn't add my common difference to the first term, right? N minus 1 times, it gets added. So I need to divide by 13. So D is 18. So I need to put 18 inside my sequence. So I'm going from term 1 up to term 14. I'm starting at 25 and I'm adding 18 as my common difference and minus 1 times. When you type this in, it's under the math key and you can scroll all the way down. Just check that this is also going to produce the same answer as your formula. So math. So the math summation, it looks like this. You type the variable key x, you type 1, arrow over 14, and then remember we put our whole function inside this parentheses. 25 plus 18 parentheses n minus 1 parentheses. So we're inside their parentheses the whole time. You really need to be comfortable doing it both ways, formula or sigma notation. Sometimes one's easier than the other. We were just doing the first problem on 509, just showing that whether we use the formula or sigma notation, we get the same amount. And just practicing writing these, you know, really gets you practicing with arithmetic sequences, how to write them, how to find the common difference. All right, so let's do example B together both ways. And then when you get down to example 2, you can use whichever way you prefer. So they've given you, again, the first term, the last term, and the number of terms. So you can easily write the formula because you've been given all the information that you need. If you have 18 terms, you would have 9 pairs, right? And the first term is 1472, and the last term is 2441, and then that will produce an answer. When you look down below here, they did not give you, what do they want? S sub 50? They didn't give you what the 50th term was. So in order to use the formula, you'd have to generate the 50th term for yourself down on example 2. So sometimes you might have information that leads you to do one of the two methods. So I would do whichever is easier. Did someone type in this one and did you get a number? What'd you get? 352.17. So let's do it using sigma notation and make sure that we get the same result. So I'm going to do the sum from the first to the 18th term in the pattern. And then I have to write the formula for myself. I'm starting at 1472, and I'm adding something n minus 1 or x minus 1 times. So we said, how do we figure out the common difference? Figure out your total distance and then divide by the number of terms. But in this case, we want to divide by 17, right? Because we only added the common difference 17 times to get to the 18th term, because the first term doesn't count. You don't add the common difference. So I'm going to do 2441 minus 1472 minus 1472, and I'm dividing by 17. So my common difference would be 0.57. Did someone else get that? Okay, so I'm adding 0.57 as my common difference n minus 1 times. So practice typing that in to make sure you're really good at getting it correct on your calculator so I can troubleshoot for you. And let's make sure it comes out to the 352. So it's under the math key, summation. N goes from 1 to 18. And then I'm starting at 1472 and going up, parentheses, n minus 1 times. Uh-oh. Oh, what? Oh, I didn't do the times the 0.57. Oops. Times 0.57, right? N minus 1 times. There we go. 352.17 is the same thing, right? I knew they had to come out the same, so. All right, you try example 2 before we do a couple examples on the back. This means find the 50th sum, right? It's called 50th partial sum or S sub 50. You're going from term 1 to 50. You need to figure out the pattern and generate term 50, or you could use the sigma notation. Just do it one way. You don't have to do it both ways. So see if you can figure out A and B. Now that you have some application problems, and then I'm going to have you try the guided practice on the next page and maybe jump back to that 507 that we skipped. So this says in a staircase, the bottom step has 28 bricks, and then each step has 2 more bricks than the step below it. So it's kind of like, you know, fanning out like this, more steps each time. There's a total of 50 steps but to get you to the top of the staircase. How many bricks are in the 50th step? That's kind of like A sub 50. And then how many total bricks are in the staircase? That's S sub 50. So one of them wants you to do the arithmetic sequence part, and one of them wants you to do the arithmetic series part. So let's do 3 together, and then you can try 4 because it's kind of the same problem. So you've got your sequence, right? 28 is the starting value for A sub n. And then each step has 2 more bricks. So your sequence would be 28, and you're adding to n minus 1 times. So you're going to plug in 50 to generate the 50th step, right? So 28 plus 2 times 49. So there are how many? 126 steps in the 50th row, right? So then, now that I have 126, if you want to do the formula, you could, because you know that you start at, what, 28, you end at 26, you know the first and the last term, and there would be 25 pairs. So you could either do it that way, 25 times 28 plus 126, or you could do the sigma notation way, summing from 1 to 50 of that sequence. And I know there's a couple problems like this on the homework. All right, so how many do we get? So it's 25 and then 28 plus 126. Is it 3850 that you got? Okay, so you're going to try, you can try 4 and 5. One is about, you know, layers of the logs, kind of like the steps, and the other one is depositing money in piggy bank. So I'll let you try those and I'll go over them in a minute. If you finish, you can go on to that next page of 4 questions. So there are 15 in the first layer, then 14, then 13, and they want to know how many logs are in the stack. So you're doing from 1 to 15 of 15 minus 1 times n minus 1, right? So x goes from 1 to 15 of 15 minus 1 times n minus 1. Did you get 120 logs in the stack? Yeah? Okay. And then on the next one, they're putting in, what, 75 additional cents each day. How much would he drop in the piggyback on May 19th? So that's the A sub n equals 1 plus 0.75 n minus 1. And they want you to plug in May 19th, right? So 1 plus 75 cents 18 times. That would be 1450. Is that right? And then what's the total 30 days? Are there 30 days in May? No, 31 days in May, right? So the sum from 1 to 31 of that. Let's see. So summation from 1 to 31 of, what is it? $1 plus 75 cents and minus 1 times. Is that right? 379.75. That's what we got. All right, so now you are trying these back 4 problems if you haven't started them yet. And when it says find S sub n, that just means find the summation because they're telling you what n is. And this one, like, they want you to do the 42nd. So sometimes the information is a little bit hidden, but you can't do an infinite sum, right? It has to stop somewhere. So you have to find where it's telling you to stop your sum, because an infinite would go on forever and you'd keep adding and adding and adding. So try 1 through 4 on that page. Yeah, so I personally would do the formula for this one because you have the first and the last and the number of terms. But when you cut this in half to get your pairs, it's okay to get a decimal. You could have a decimal number of pairs, right? So you would do whatever 23 halves is. Was that 11 and a half? No. 11 and a half, right? Yeah. So, and then you're going to do your first term plus your last term. I would just do it with the formula this time and not the sigma notation. I'm going to put up the answer to number 2. Did you get that one yet? I'm doing the sum of 1 to 42, 324, and it's going up by 7, right? 7 n minus 1. So I would use the sigma notation on number 2 because they didn't give you the last term. If not, you'd have to generate the last term, A sub 42 first. Sum of 1 up to 42 of 324 plus 7 times n minus 1. 19,635. Did you get that? Oh, yeah. I was thinking it was just the next, yeah, plus 27. Thanks. I was just thinking it went from 24 to whatever, 31, I think. Thank you. So if I change it to 27, it's 36, 855. Is that what you got? Okay. Got to have the right common difference, right? Or else you're going to be off by a lot. How many terms must be added whose first term is 11, common difference is 3 to obtain a sum of 1092? I think you'd have to guess and check this one, wouldn't you? Or actually, you could do the number of pairs. The number of pairs. No, No, because you'd need the first and the last term. Nope, so I think I would just do the sum from 1 to guess and check, whose first term is 11 and whose common difference is 3. And actually, you can put this in your, can you put this in your y equals menu? X equals 1 to x at the top, can't you? I'm pretty sure you can put it in your y equals menu, math summation, say x goes from 1 up to x. I don't know, I think it works. 11 plus 3 times n minus 1, and go to your table. Let's just make sure it shows up in our table. Yeah, so then you've got the running sum in your table. So you're just using a lot of variables because it's x equals 1 up to x, and you're putting an x there. But if you, that's just a shortcut. If instead of guessing and checking, then you could skim down in your table until the sum gets to be whatever we wanted, 1092. I'm going to jump. Is it 30? Oops. Oh, too far. 1092. I think 24 would be the answer, right? Because that's the last term is 24. So does that sound right? Did you actually guess and check and get 24, or did you look at? Yeah, guess and check would work. I mean, it wouldn't take you that long to get there, I don't think. The table. Yeah, there's no way because, yeah, we're going to learn other methods, but for this particular type problem, or else you'd have to like generate the last term, then use the formula. I can't think of another way to solve it algebraically. I was going to try to do that with my number of pairs, but you can't do the number of pairs without knowing your first and your last term. Let's see, this is the theater, and so this is generating, seats are in the first 3 rows, S sub 3. What number row must seat 205 be in? So that's kind of a guess and check. Like you'd want to try, you know, S sub 6, S sub 7, S sub 8. When do you go over 205? Because then it would be in that row. And then how many total seats? That would be S sub 30. So why don't you try that last problem, number 4, and then